All right, guys, before we get into some of the problems we're going to look at today, I saw a number of people struggling with this number 7 from the quiz, and so I figured I'd give you a heads up. I'm seeing a lot of people doing it this way, where they're taking everything in the original problem and rewriting it in terms of sine and cosine. And, you know, this method works on a regular basis, doesn't work all the time. And then they get right here and they say, okay, I need a common denominator to actually combine these. So this denominator is sine and this denominator is sine to the third power. So we'd have to multiply above and below over here by sine squared to get the same denominator, sine cubed of x. So you get to here. And then we combine these and we notice then that we have a common factor of cosine of x in the numerator. So we can factor that out and we're left with sine squared x minus 1. And anytime you see sine squared or cosine squared, you got to be thinking Pythagorean identities. So if we go to our Pythagorean identity right here and we manipulate that so that we have sine squared minus 1, which means I have to bring the 1 over, okay, to get sine squared of x minus 1, which means the cosine squared has to move over and become negative cosine of x. So we can substitute that for sine squared x minus 1 right here to get this. And of course that gives us the opposite of cosine cubed over sine cubed, and we know cosine over sine is cotangent, so this gives us the opposite of cotangent cubed. Now there's nothing wrong with doing it this way, okay, but there's an easier way to do it, okay. You know, if we go back to that original problem and I take a look at it, the first thing I notice is I have a common factor right now of cotangent. Okay, so I'm thinking, okay, well, let's factor that guy out first, cotangent of x, and then I'd be left with 1 minus cosecant squared of x, like this. Now, this guy right here, just like when you see sine squared and cosine squared, when you see cosecant or cotangent squared, you got to be thinking about your Pythagorean identities. Okay, so we go right here to our Pythagorean identities, right here, okay, and we have cotangent squared plus 1 equals cosecant squared. Okay, so I've got cotangent squared of x plus 1 is equal to cosecant squared of x. Well, I need 1 minus cosecant squared, so I have to bring this guy over, and it'll go from positive to negative, which means I have to move this guy over. Okay, so I'm going to get 1 minus cosecant squared of x equals, this will become negative when it moves to the other side, cotangent squared of x. Okay, so I can substitute this for that right here, and I get cotangent of x times the opposite of cotangent squared of x, which of course gives me the opposite of cotangent cubed of x. Okay, I think that every single one of you would agree with me, this is a heck of a lot easier to do than this, okay, up here. Okay, so I'm not saying this is wrong, okay, and I'm not saying that this method of going sine and cosine doesn't work. It works on a regular basis. It doesn't work 100% of the time, but it does work on a regular basis. Okay, so there's nothing wrong with doing it this way. Okay, but boy, this is a heck of a lot easier to do right here. So I just wanted to bring that to your attention. Okay, so let's see. Going back to what we started working on yesterday, get a couple more like these. So we want to simplify by combining the fractions. Okay, so I've got to find a common denominator. Okay, so it looks like this denominator has one factor of 1 minus cosine of x, and this guy has one factor of sine of x. So it looks like our common denominator will be 1 minus cosine of x times sine of x. Okay, so if that's the case, that means I have to take this guy on the right, and I've got to multiply above and below by 1 minus cosine of x, and 1 minus cosine of x, okay? And then over here, I'm going to have to multiply above and below by sine of x and sine of x, like that. Okay, so let's see. On the left-hand side, sine times sine, I'm going to get sine squared of x all over sine of x times the quantity of 1 minus cosine of x. Okay, plus over here, well, notice I'm going to get that same denominator, sine of x times 1 minus cosine of x, like that. And up above, notice I have a binomial times itself, so I'm going to end up with a perfect square trinomial that'll result from squaring 1 minus cosine of x squared. Okay, so let's see. I can combine this entire thing over the same denominator, sine of x times 1 minus cosine of x. Okay, so I have this sine squared of x right here, plus, and let's see, I expand this. I'm just going to do it in my head using the formula. So we take the first term and square it. 1 squared is 1, minus 2 times the first times the second, so that'll give me 2 cosine x, plus second term squared. So when I square cosine of x, I get cosine squared of x. Okay. Now, up top, I see this guy paired up with this guy right there. And we think about our Pythagorean identities. I've got sine squared x plus cosine squared x equals 1. So I know that these two added together give me 1. Okay, so I have that 1 from these two plus this 1 right here minus the 2 cosine of x all over sine of x times 1 minus cosine of x. Okay, up in the numerator, we just collect similar terms. 2 minus 2 cosine of x all over sine of x times 1 minus cosine of x. And notice in the numerator, I have a GCF of 2, so I'm going to factor that guy out. And when I do that, I'm left with 1 minus cosine of x all over sine of x times 1 minus cosine of x. And notice that the 1 minus cosine of x cancel off, so I'm left with 2 over sine of x. Now, some people would say that's okay. I think you got to keep going with it, because I can still simplify this more by getting rid of this fraction bar. Okay, in my head, I should be thinking this is the same as 2 times 1 over sine of x. Okay, and so we know that the reciprocal of sine of x is cosecant, so the best form of the answer would be 2 times cosecant of x. Okay, there we go. Okay, and it can't get any simpler than that. Okay, one down. Got another one. Okay, let's see. Same sort of problem. So it seems that I've got a factor here of 1 plus secant of x. I got a factor here of 1 minus secant of x. So it seems to me the common denominator will be 1 plus secant of x times 1 minus secant of x. Okay, so over here I have to multiply by 1 plus secant of x above and below, 1 plus secant of x. And over here, I've got to multiply by 1 minus secant of x. 1 minus secant of x and 1 minus secant of x, like that. Okay. All right, so let's see. Okay, this guy over here. Okay, let's see. What am I going to want to do? I think I'm going to distribute this cosecant through this 1 minus secant of x. Okay, so that'll give me cosecant of x minus cosecant of x secant of x right there. And then down below, notice that these guys are conjugates of each other. So anytime you multiply conjugates, you get a difference of squares. Okay, so when I multiply them, I'm going to get 1 minus secant squared of x, like that. Okay, let's see what happens over here. Okay, well, I distributed the cosecant through this guy, so I might as well do it through this guy. Okay, so I get cosecant of x plus cosecant of x secant of x. And as we said, these are both conjugates, so I know I'm going to get a difference of squares, 1 minus secant squared of x. Okay, now, I know one thing. I'm definitely looking at this 1 minus secant, and I'm thinking Pythagorean identity. Okay, so I go here, which one? So right here, tangent squared plus 1 equals secant squared. Okay, so I know I'm probably going to have to use this. Tangent squared of x plus 1 equals secant squared of x. That might come into play. So let's see what happens here. Okay, I combine everything over the same denominator, okay, which is 1 minus secant squared of x. Now let's see what we got here. Notice this guy right here is similar with this guy, and they're opposite, so they cancel each other out. Okay, and notice this guy and this guy are similar as well. They're not opposite, so we can combine them, and that'll give us 2 cosecant of x. 2 cosecant of x. Okay, so let's see what I can do with this denominator here. 2 cosecant of x. Okay, I need 1 minus secant squared. So I would have to move this guy over to make him negative. So that would give me 1 minus secant squared of x on the left, which means this guy has to move over to the right and become negative. It gives me negative tangent squared of x. Okay, so I can substitute negative tangent squared of x in here. Okay, so negative tangent squared of x. Okay, so just like this last one, okay, I get to this point and I'm thinking, okay, like this, it's like these guys. I'm thinking, okay, can I simplify that? Okay, so I'm thinking in terms of, let's get rid of the fraction bar to begin with. Okay, all right, we know the whole thing's negative because we have positive divided by a negative. So that's like negative 2 times cosecant of x times, well, this would be 1 over tangent squared, so that's cotangent squared of x, like this. Okay, let's see what happens here. Okay, so I've got that negative 2. Cosecant is the reciprocal of what? Sine? All right, so that's 1 over sine of x. And cotangent is cosine squared of x over sine squared of x, like that. Okay, and I take a look there and notice that there is really nothing to cancel off. Okay, and so if I keep going, it makes it even, uglier. Now you have negative 2 times cosine squared of x all over sine cubed of x, and you look at this guy and you say, well, that's just getting uglier. Okay, so we go back and we say, okay, this guy and this guy, which one's better? Well, obviously this guy's better. The reason being is it has one less symbol in it, so it's simpler. Up here we have a fraction bar, right here we don't. So my final answer here would be negative 2 cosecant x cotangent squared x, like that. Okay, and let's see if we got that. I want to make sure we got it right. I'm pretty sure we do. Okay, so let's see. That gives us 2 cosecant. Those guys cancel off. This guy right here, that becomes negative tangent squared. I agree with you right there. Okay, so we bring that from down in the denominator up above, so that becomes cotangent, and we put the negative out front. Okay, so I like this so far. All right, so that's 1 over sine, and that's cosine squared over sine squared. Yeah, there's nothing else we can do. Okay, so this would be your best form of the answer. Okay, and there's really nothing else we can do with that. Okay, let's see. I don't see anything else that we could do with that guy, so let's go. Okay. All right, let's see. All right, another type of situation. Okay, and this is like the bane of every trig student's school year. Okay, verifying a trig identity. This is the trigonometric version of doing a geometric proof, okay? Which, of course, if you remember, last year when we started doing proofs, everybody struggles with them. And then you get better over time. So it's the same thing here with verifying trig identities. Okay, so a trig identities, okay, it's going to be some equation. It'll have an equal sign in it where you have some sort of trigonometric expression on both sides. And we have to verify that the left-hand side and the right-hand side are actually equal to one another, okay? So one way to do it is we start on one side and manipulate it as needed and show that it's equal to the other side, okay? And as a general rule, this is a general rule, okay? You always start with the side that seems more complex, okay? So that seems a little busier. So if we start on the side that seems a little busier and we can simplify it down to what's on the other side, then we verify the trig identity, okay? So we've been working on these different types of simplification, so let's get through one of these guys and then we'll do some more tomorrow. Okay, so we gotta verify this guy. Okay, so I gotta verify that tangent squared is the same as this guy. Okay, so if we follow our general rule and we say, okay, start on the side that's busier, clearly the right-hand side, okay, is busier. So I say, okay, can I take this right-hand side and manipulate it and end up coming up with tangent squared to show that the right-hand side is equal to the left-hand side? Okay, so I'm looking at this long string of things, okay, and notice that, I don't have a GCF that I could factor out that would help me. So considering what we know right now, I'm thinking, okay, why not go and write it in terms of sine and cosine and see what happens? Okay, so let's do that. Okay, so let's see, secant, okay, is 1 over cosine of theta. Cosecant, okay, is 1 over sine of theta. And tangent, okay, is sine theta over cosine theta. And then I have that minus 1. And we say, okay, can I get anything to cancel off? Well, notice I can get this sine to cancel with that sine. Okay, and then when I multiply them together, I get 1 over cosine squared of theta minus 1. Okay, so already we're a little bit simpler. Okay, so this right here is the reciprocal of cosine squared. So I take a look at that, and I say, okay, the reciprocal of cosine squared is secant squared. So this is the same as secant squared of theta minus 1. Okay, and now notice I'm looking at that secant squared and the 1, and I am thinking about Pythagorean identities. Okay, tangent squared plus 1 is equal to secant squared. So I have this guy. Tangent squared of theta plus 1 equals secant squared of theta. Okay, and can I manipulate it to get this? Well, notice I can move the 1 over so it becomes negative. Okay, so I would get tangent squared theta equals secant squared theta minus 1. So that means where I have secant squared theta minus 1, I can substitute tangent squared theta, and notice we get tangent squared theta. And notice I've shown that the right-hand side can be simplified down to the left-hand side. So I have verified that this identity is true. Okay, so we're in good shape. Okay, absolutely. Okay, now these guys again take some practice, and none of them are the same. So it's just like a geometric proof where over time you start seeing some similarities, but every proof is different. So it's going to be the same thing here. Every identity that we're trying to verify is always going to be different. Okay, so it just takes practice. Okay, so that'll wrap it up for today. You guys make sure that if you need anything, don't hesitate to reach out. Don't hesitate to stop by. I left you a message on Google Classroom yesterday about that. Be safe out there, and I miss all of you.